All right. It says a block on a surface with negligible friction is held against a compressed horizontal spring. The block is released. Which of the following statements describes the force exerted on the block and the motion of the block immediately after the block is released? So let's draw the picture first, okay? So I have the block is on a surface. So here's the surface. This is my block. And it's up against something, and the spring is wound really tight. Okay? And that's compressed. So there's a bunch of stuff going on there. And then, so let's reread the question. It says the block is then released. What's going to happen when we release that block? And it says negligible friction. You know what that means? This is like ice. We ignore the friction. So there's a couple of things. The spring is pushing this way, and there's a force that's being applied that's going that way. If the block isn't moving at that moment in time, the sum of the forces in the x direction equals 0. Okay? And because there's friction, we can ignore gravity, we can ignore the normal force, we can ignore friction. Okay? Now, once it's released, what's going to happen? Well, as this block moves away, we release it. What's going to happen to this force here? The spring force. Well, it's going to decrease, right? Or wait, let me rephrase that. Let me back up. This one will actually increase because it's pushing away, right? It's trying to restore itself. What about this one? This will decrease because the net force is going in the positive x direction. Okay. So the answer for that one, and the wording that they used, the force exerted by the spring is decreasing and the speed of the block is increasing. Did they say it was compressed or stretched? Well, let me think. Yeah, the net force would be, oh, that's weird. It's the opposite, isn't it? The speed of the block is definitely increasing. I guess at some point in time it would be decreasing, right? Because if the spring goes too far, the spring will want to go back. So eventually it does decrease. It just depends on where you're talking about it, right? Like if that, at some point, if you stretch the spring out all the way, this will be 0 and it'll reverse itself. So at some point it decreases. But I don't know. That's a tough one because let me reread it and see if there's a clue. The block is then released, which describes the force exerted on the block and the motion of the block after the block is released. Yeah, the force over here would be the greatest, and when you let go of this force, it's basically gone. Yeah, so this would almost a better way to word that would be because remember, an object in motion can remain in motion, right? So this one is almost gone. There's almost no, like, if I'm pushing this with my hand and then I remove my hand, there's no force going this way. Now, whatever this force is, as soon as this spring starts to compress, it would be a little shorter. It would be a little shorter. So this force, but once this is in motion, the velocity increases, right? Because there's still an acceleration, right? So remember that force is equal to the mass times the acceleration. And so, but once that object has a velocity, right, if the acceleration slowly declines and goes to zero, if there's nothing acting on it, like friction, it will continue. So while there's an acceleration on the object, the velocity will increase, but at some point, the acceleration will approach zero, right? So your acceleration will approach zero or close to nothing. And then when that happens, it's still going forward. So yeah, they're right. This is the correct answer, C. Even I had to think that one through. Any questions on that one? How many of you guys got that one? Yeah, that was it's a weird one.